Why time travel might be possible, wormholes simplified. Have you ever wished you could go back in time and fix a mistake? Or maybe jump forward and see what the future holds? While time travel has always felt like a far-off dream, reserved for science fiction movies like Interstellar or Back to the Future, some real scientific theories suggest that it might actually be possible. And it all starts with one mind-bending concept: wormholes. Let's start with the basics. A wormhole is like a shortcut through the universe. Imagine space-time as a two-dimensional piece of paper. If you draw two dots on it, say Earth and a distant galaxy, and fold the paper so the dots touch, you've just created a wormhole. Instead of traveling the long path across the paper, you jump through the fold. That's the magic of a wormhole. It bends space and time to bring two faraway points closer together. But how does this relate to time travel? According to Einstein's theory of general relativity, massive objects like planets and stars bend the fabric of space-time. A wormhole is a theoretical tunnel created by this bending, connecting two distant regions of space and potentially two different times. If one end of a wormhole could be accelerated to near-light speed and then brought back, time would slow down on that end due to time dilation. Thanks, Einstein. When the wormhole is stabilized again, the two ends would no longer be in sync. One would be in the past, the other in the future. So technically, if you could enter the right end, you could travel to the other and emerge in a different time. Sounds like science fiction, right? Surprisingly, it's science fact, theoretically at least. Wormholes are solutions to Einstein's field equations, but they have a big problem. They're incredibly unstable. The moment you try to send even a single atom through, the wormhole collapses. Enter the idea of exotic matter, a mysterious form of matter with negative energy density. Unlike normal matter, exotic matter could theoretically hold the throat of a wormhole open. Scientists haven't discovered exotic matter yet, but quantum physics gives us hope. Effects like the Casimir effect already show that negative energy exists in small, measurable ways. The idea of using wormholes for time travel became even more fascinating thanks to physicist Kip Thorne, who, in the 1980s, proved that under certain conditions, involving exotic matter and a lot of luck, wormholes could be used to travel not just through space, but through time. Thorne's work even inspired the movie Interstellar, where time dilation plays a major role. And while building a time machine is still beyond our current technology, the math does suggest it's possible, if we can figure out how to control the forces involved. But the possibilities don't end there. Some theories suggest that naturally occurring wormholes might exist in space, perhaps hidden inside black holes, or even within the quantum foam, the smallest fabric of the universe. If we ever found such a wormhole and found a way to stabilize it, we might not just explore the stars. We could witness ancient history or the future firsthand. Of course, this raises big questions. What would happen if you traveled back and changed the past? Would it create a new timeline, or is everything fixed in a single loop? These paradoxes, like the famous grandfather paradox, keep philosophers and physicists awake at night. Some interpretations, like the many worlds theory, suggest that each decision creates a new parallel universe. So maybe by traveling back, you'd just enter another version of reality. In the end, wormholes may remain an unsolved mystery for now, but exploring them offers more than just the hope of time travel. It pushes us to ask deeper questions about the nature of reality, the flexibility of time, and the ultimate limits of human understanding. With every equation and experiment, we inch closer to truths that once seemed impossible. So is time travel possible? Maybe. Not today and not with a DeLorean. But with wormholes, exotic matter, and a better understanding of the universe, the door is at least theoretically open. The universe is far stranger and more exciting than we ever imagined. Like and subscribe.